So now in this video we'll be doing about the preparation of bases. So preparation of bases is pretty simple. So if in case we remember this fact that all the bases will have either O2 minus anion or OH minus anion. So you need to choose such products which will such reactants. You need to choose such reactants which will give rise to a product, and this product must always have an O2 minus anion or OH minus anion. So now let's just go through all the types of preparation. So first thing is a very simple form of preparation, which is metal plus oxygen will give you metal oxide. Since this metal oxide will have an anion O2 minus, this is supposed to be a base. So now for instance, when you take Mg and then O2, and then you'll be getting 2 MgO after you balance this. But writing the equation Pb plus O2 giving 2 PbO is wrong, since we have discussed the fact that PbO, which is lead oxide, is not a proper example of a base. It is not a proper example of a base because of the reason that when it reacts with an acid, it does not only give you salt and water. Apart from that, you will be getting a non-metal which is known as chlorine diatomic molecule. So because of that, this reaction cannot be written. And then apart from that, you can write the other common example, Ca plus O2 giving you 2CaO, and then Na, which is sodium, plus O2 giving Na2O, and then 4 units of potassium plus oxygen gives you 2K2O. So now all these sequences are supposed to be certain oxides which will have O2 minus as its anion, and then you know how it's formed. A metal plus oxygen will give you an oxide which is the base. This is the first way in which you prepare bases. So now the second way in which you prepare bases will be when you make a metal react with H2O. It's just not oxygen. When you make it react with H2O, you will be getting a metal hydroxide. This metal, that means this base will be having OH minus in it. Apart from having OH minus in it, you will also be getting hydrogen. And then you know how to identify whether the gas is hydrogen or not. First is the popping sound that comes out, and next is hydrogen puts off fire. So based on these two factors, you can identify that the gas which has been released is H2. And then we will write few examples now. So now let's take Na, which is the most common example, and you make that react with H2O. The reaction will not be balanced, as I told you before. So Na plus H2O will give you NaOH plus H2. Likewise, potassium plus H2O will give you KOH plus H2. This is supposed to be caustic soda. The common name is supposed to be caustic soda. So since the common name is caustic soda, your actual name or the chemical name is sodium hydroxide. Likewise, this is caustic potash. This is caustic potash. So since this name is caustic potash, your actual name or your chemical name will be potassium hydroxide. And then afterwards you will take calcium. So Ca plus H2O will give you CaOH twice, and then H2. So now here this thing is known as lime water. Slaked lime, or can be lime water. What is the common name for this? This is slaked lime or lime water. And you know where you make use of calcium hydroxide. Calcium hydroxide is made use of in the case where you test for the presence of carbon dioxide, because it turns the lime water milky in nature. So then this is supposed to be calcium plus water gives calcium hydroxide and hydrogen gas. You know how to test the presence of H2, and you know how to find whether the compound which has been produced is calcium hydroxide. For that you can take a substance and you can pass carbon dioxide in it. If the substance turns milky, that is always because of lime water, because only lime water or slaked lime turns milky when carbon dioxide is passed through it. So now this is supposed to be the second method of preparation. So now third method of preparation is when you have a metal oxide as your reactant. Now first case you have taken just a metal as a reactant and you made it react with water. Next you will take metal oxide. You will take metal oxide as a reactant. You will make it react with water. You will be getting metal hydroxide but no hydrogen. You will not be getting hydrogen. So now here the reactions, now we will take Na2O, and then you will be getting H2O. So you will be getting NaOH twice. You have to just put 2 Na, so now your number of hydrogens become 2 and number of oxygen also will change accordingly. So I think this equation is not completely balanced. You will have to take care and you have to balance it again. So now I am rubbing off the balancing part because that can be done patiently. So first thing is Na2O. When you make it react with water, you'll be getting an oxide. So no, this will not be Na. Now I'm sure you will understand what the mistake is. The mistake is it is just NaOH. It is just NaOH. Why? Because Na is always plus 1, OH is minus 1. This is a mistake which I made here. So Na2O plus H2O gives you NaOH. So now to balance, just put 2 here. Everything is completely balanced. Now I am sure you understand what mistake I made. The mistake I made here is, please make sure the balancing of the cation and anion, and then you will form the formula for your metal hydroxide. This is a very casual error. Next is when you take calcium oxide and you take H2O, you will be getting CaOH twice, and then you are supposed to balance it. Now you are supposed to balance. CaO plus H2O gives CaOH twice. So now next one is supposed to be K2O, and then you will have H2O, and you will be getting 2KOH. Because an oxide, when you react it with water, you will be getting a hydroxide and no other substance. This is supposed to be the reaction of metal oxide plus water. So the next one is reaction of metal sulphides. Let's not go in order. So now we'll say metal sulphide, and then when you make that react with oxygen, you'll be getting metal oxide, and apart from that you'll be getting SO2. And you know how to find the presence of SO2 as well. SO2 is found when you pass this gas SO2 through acidified potassium dichromate. It turns green in color, which means the gas which you have passed through is nothing but sulfur dioxide. So now acidified potassium dichromate will indicate the presence of the gas SO2. And then when you take metal sulphide, so take metal sulphide, like for example you take Na2S, and then afterwards when you pass it through oxygen, so you'll be getting Na2O, and then you'll be getting SO2. Likewise, when you pass K2S and then you pass it through oxygen, you'll be getting K2O, and then you'll be getting sulfur dioxide. Sulfur dioxide can be identified as in the way I told you, and these are all bases because they have O2 minus anion. So next is, if you take CaO, when you pass it through oxygen, you will be you take CaS, pass it through oxygen, you'll be getting CaO, you'll be getting SO2. So whenever you take a metal sulphide, when you make the react with oxygen, you'll be getting a metal oxide, and then you'll be getting sulfur dioxide. So this is it. And then the next one is reaction of a salt, any salt solution with an alkali, in the bracket you can just write base, with a base which is an alkali. That means this base must be soluble in water completely and furnish OH minus ions. And then this will give rise to another base which is a normal base. Normal base in a sense, I mean the base is not very strong like an alkali. And then apart from that, you will be getting a normal salt. Here normal salt in the sense, you will not be getting NaHSO4. NaHSO4 is an acidic salt. Here you might be getting salts like Na2SO4. So you will not be getting an acidic salt, you will be getting a normal salt. And a normal base in a sense, a base which is not very strong in nature. It is not an alkali, to be very specific. So now let's take salts like FeSO4, and then let's take a base like NaOH. And now what we'll be getting? We'll be getting a normal base. See, now I told you, we'll be getting FeOH twice. FeOH twice is a base, but it's not an alkali. Why? It does not dissolve in water completely. So now let's just put 2 NaOH for time being, and then your salt is Na2SO4. Now didn't I say? I said NaHSO4 will never be formed because that is supposed to be an acidic salt. Na2SO4 will be formed because that is a normal salt. So next one is, you can take Fe2SO4 thrice. Fe2SO4 thrice can be taken, and then you can take KOH, and then you have to take FeOH thrice. You have to take FeOH thrice, and then you are supposed to take K2SO4. For K2SO4, what you are supposed to do? You are supposed to put 3 here, and then you are supposed to put 6 here, and then you are supposed to change accordingly. You are supposed to change accordingly till all your elements are changed. Now I balance as much as possible. Please recheck while watching the video. If there is a mistake, please don't copy it as such. You can balance it later. So now the next way in which you do is, apart from this reaction, next is when you take certain carbonates or nitrates. It's just mere thermal decomposition of carbonates and nitrates. So next is thermal decomposition of carbonates and nitrates. So now let's take a carbonate which is calcium carbonate and do thermal decomposition. First we are doing carbonates. You will be getting CaO and CO2. This is supposed to be a base because it's an oxide with O2 minus, and then you take Na2CO3, you will be getting NaO and you will be getting CO2, 2Na, and then you are supposed to balance it. I am not balancing it now. And then if you get K2CO3, you will be getting K2O, so it's Na2O, I'm sorry, it's Na2O. I'm sure you know what mistake I made. It's the valency error. So Na2O should be here, and here K2O, and you have to get CO2 as such. And then apart from that, whatever carbonate you take, when you heat the carbonate, you will be getting just the oxide and carbon dioxide. And you know how to find the presence of carbon dioxide, and other one is a base that you obtain. So this is supposed to be thermal decomposition of of your carbonates. Thermal decomposition of carbonates is heat the carbonate, you will be getting your oxide, which is the base. Other one is carbon dioxide, which is the gas. Next is for nitrates. First we have done carbonates, now we will do nitrates. Now when you take lead nitrate, you will be getting your oxide PbO, and then you will be getting O2, you will be getting NO2 also. So this is supposed to be your base, because when you heat a nitrate, you will be getting three products. One is your metallic oxide, other one is oxygen, and then next is nitrogen dioxide. Likewise, when you heat a metallic carbonate, you will be getting a metallic oxide and carbon dioxide straight away. So, and then balancing alone you will have to take care, as I told you. Next is when you take calcium nitrate, and then you will be getting CaO, H2O, NO2. So, and then afterwards you also know that if they ask you a preparation of a base, you can't take this sometimes, because lead nitrate, you know the problem regarding lead nitrate, because the oxide sometimes will not produce chlorine. So it's better if you choose a better cation, you can take Ba. If you take Ba, probably it can be better, because the one which is PbO, there are many exceptions depending on the condition or depending on the acid that you use. Your conditions will differ. That means your definition also must be changed. So a better change is you can use Ba. But then I gave this example of lead to explain that when a nitrate is heated, you will be getting just an oxide, oxygen, and then nitrogen dioxide. For that purpose only I mentioned lead nitrate as an example. You need not get confused. So now next is when you take sodium NaNO3, you will be getting Na2O, O2, I'm sorry, I would have mentioned it wrong here, O2, and then you will be getting NO2 here. Okay, so now it is always just an oxygen. Sorry if I'm confused you. So it's always an oxygen, NO2, and then CaO, which is supposed to be your oxide. It can be CaO, Na2O, BaO, it can be anything here. So now before I wind up, I will just give a small brush up of everything, like in short, the various ways in which you prepare a base. So the first way is making a metal react with oxygen. I am just going to write the short form so that you will never forget it. So first is metal plus oxygen gives you metal oxide, first one. Next is metal plus H2O gives you metal oxide plus H2, sorry, metal hydroxide. So it should be metal hydroxide plus H2. Next is metal oxide plus H2O gives you metal hydroxide alone. Next is metal carbonate and metal nitrate. Let's do both of it together. On thermal decomposition of both, you will be getting metal oxide in both the cases, and then here you will be getting CO2 gas, and here it's O2 and NO2. And then next is metal sulphide. Metal sulphide is when you take a metal and then add sulphide. So when you take metal sulphide and then when you pass oxygen through it, you will be getting metal oxide plus sulfur dioxide. And then I hope I have covered all the ways. And the last method is when you take an alkali, and then when you take an alkali, combine it with a salt, you will be getting a weaker base and it will be getting a normal salt. So now these are the ways in which you prepare the bases, and then in the next video you will be doing about the chemical properties of bases, which we have already discussed once in a while. So thank you so much, and please do keep watching the other videos as well.